This is where we left last week. The factor theorem, second result. So first result was if we can find a constant which will make the polynomial equals to 0, that constant is actually the 0 of the polynomial, and with the help of the 0 of the polynomial, we can make a factor, a linear factor for that polynomial. This is what we did in the first result of the factor theorem. So if you can find out a 0 of the polynomial, you can make a factor of the polynomial. The second result was that if you have been given that there is a linear polynomial which is a factor of the polynomial already. I have taken this example in second part where px is given and gx is x minus 3 and it's a factor of px. That would mean कि अगर मैं gx में से x की वैल्यू निकाल के px में पुट करती हूँ तो उसका आंसर डेफिनेटली 0 होगा. I don't need to check it. I can write this down that P of 3 will be equal to 0. And such kind of result is actually helpful in finding out any coefficient of the polynomial which is missing. So I have taken this example over here. I think you can see it on the screen. I have a polynomial px which is incomplete actually. The last term, the constant term is missing. It could happen to any of the coefficients. जरूरी नहीं है कि constant coefficient missing हो सकता है कोई किसी भी term का coefficient missing हो और उसको किसी और variable से represent किया गया हो. तो यहाँ पे हमारे पास जो polynomial है, the variable is x. The variable k is actually representing a constant here. So our purpose is to find out that value of k using the fact that x minus 1 is a factor of px. तो यहाँ पे हम अपनी factor theorem लगाएंगे. हमें already factor दिया हुआ है तो हम factor theorem use करेंगे. तो यूज करने के लिए करना क्या है, आपको जो फैक्टर आपको बताया हुआ है उसमें से आप x की वैल्यू निकालोगे और वो वैल्यू आप px में पुट करोगे. पुट करने के बाद आपका एक्सप्रेशन जो भी बनता है इट कैन बी टेकन इक्वल टू 0 बिकॉज ऑफ फैक्टर थ्योरम, and then it becomes an equation which can be solved in order to find out the value of k. And this is what I have done here. From the factor I have calculated the value of x. So this was the factor. I've taken the factor equals to 0. From there, I have found the value of x and then use value of x in px. And it is taken equal to 0. This is important. So you take that value equal to 0 and solve to find out whatever was missing in your polynomial. This is how we are going to use factor theorem in question number 3 of the exercise. So we'll do a couple of questions. I think that will make sense to you. If anyone has any questions before that, you can ask.
No, ma'am.
So this is the question that we have, question number 3 here. Find the value of k. So they are writing this down on their own, find the value of k. So you can see k is something which is missing in the polynomial. So you have to find that k. You have been given that x minus 1 is a factor of px in each of the following cases. They could change the factor in different parts. So right now we will be using just one factor here. Let's write down. This is question number 3 from exercise 2.4. So first step is to take gx equals to 0 and from there find out x. And then by factor theorem, P1 should be equal to 0. So use the value of x as 1 in the polynomial and write it equals to 0, and you should be able to find out what k is. This is how you have to do these questions. I hope the application of factor theorem is clear. We are using right now the second result of factor theorem. We will be using the first one later on in question number 5. I hope you have done this by now.
Yes, ma'am.
Yes, ma'am.
The second thing that I asked you was to revise the factorization of quadratic polynomials, because that's what the next question is about. Factorize the following. So I'm taking that up and we will be revising it side by side. If you have not done that on your own. So this is what we have here, factorize. Now you can see there are two questions here, both say factorize. The only difference is in question number 4, you've got quadratic polynomials, and in question number 5, you've got cubic polynomials. And the difference is cubic polynomials की factorization आपको ज़्यादा marks में आती है because it requires a number of steps. Sometimes the quadratic polynomial, the cubic polynomial can be factorized without using the longer method, which we will discuss when we take up that question. So just compare that. I'll show you both. But it's not applicable in all cubic polynomials. Whereas for quadratic polynomials, you have done a lot of questions last year. आपके exercise में भी थे, assignment में भी थे. So right now, most of these will be done by splitting the middle term. I hope everyone remembers how we split the middle term. If there's anyone who has a trouble with this, because this is very important, जो quadratic polynomial की factorization है, वो later on cubic polynomial की factorization में भी use होनी है. So it's extremely important that you revise the factorization of quadratic polynomials. First one is 12x square minus 7x plus 1. If you want, you can represent it as bx equals to 12x square minus 7x plus 1. Now the next step is I'm going to write this in detail, which is not required as such on your part. You don't have to write this down. So I am looking for breaking down my middle term. So middle term is minus 7x. I want to break it down into two parts. And the way I will do it is by looking at a pair of values whose product and sum should be the one I need here. So the product is calculated by taking the coefficient of x square multiplied with the constant term, and you have to take them with their signs. So product should be equal to the coefficient of x square, which is 12, multiplied with the constant term, which is 1, and the product becomes 12 here. I am looking for a pair of values, so I'll be looking for the factors of 12. मुझे factors चाहिए 12 के, and I need a specific pair of factors whose sum should be given by the coefficient of x. That's my middle term. This is actually -7. Remember, you have to take the signs along with these. So an easy way is trial and error. आप माइंड में सोचते हो कौन सी ऐसी दो वैल्यूज हो सकती हैं जिनका प्रोडक्ट 12 बनता हो और सम -7 बनता हो. It works
3
for,
and 4.
yeah, 3 and 4. 3 and 4 specifically, yes, to be specific, it should have -3 and -4. Both should carry negative with them. Only then their sum will be -7. We want the sum to be minus. So I'll just give you a clue here because कुछ क्वाड्रेटिक पॉलिनोमियल्स ऐसे होंगे जिनमें आपको बहुत क्विकली नजर आ जाएगा कि ये फैक्टर्स बन रहे हैं. समटाइम्स इट गेट्स अ लिटिल हार्ड टू थिंक अबाउट व्हाट फैक्टर्स वुड बी यूज्ड हियर. सो यू शुड ऑलवेज स्टार्ट बाय राइटिंग डाउन द फैक्टर्स ऑफ द प्रोडक्ट. आपने जब 6th 7th क्लास में फैक्टर्स सीखे हैं, आप ऐसे लिखते थे. यू रिमेंबर दिस?
Yes, ma'am.
So what I can do is I can just modify these to obtain more factors. Right now I have my factors from the list of natural numbers. I can expand these factors to integers. So what I can do is I can write this way also. -1 multiplied with -12, the product will be 12. Then -2 multiplied with -6, -3 multiplied with -4. So I've got here 6 pairs of factors, out of which the suitable one is this. इसका sum बन जाएगा -7. So that's what I'm going to use, -3 and -4, and I'll be splitting my middle term. Since my middle term contained x, each of these numbers will have x with them. So -3x, -4x. This is how I have split the middle term now. After splitting the middle term, I will be pairing up the terms, first with the second one, third with the fourth one, irrespective of anything in my mind. I can just pair them up. If I have done the splitting correctly, I will see that once I pair first, second term and third, fourth term, I will have a common binomial from both these pairs. So from first pair, do you see any common factors?
3x.
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 And what's the binomial that will be left?
4x minus 1.
4x minus 1.
And from the next pair, I don't have anything common. So I'm
-1.
Minus one.
That's
Minus
correct.
1.
-1.
And the terms will
4x
change their
plus
signs. Yes, remember,
4x.
the terms will change their signs. Now I have a product here. This is the first product and this is the second product. In both these products, the binomial is common. So I can take that binomial common and I'll be left with the monomials inside. So these are the two linear factors. And you're not supposed to write all this down. You can just work with your expression as such. ये सिर्फ मैंने रिवाइज करवाने के लिए किया है आपको. One thing, if you take up questions from textbook of NCERT of class 8, you will see that all the quadratic polynomials that were given in your book had the leading coefficient equal to 1. उनमें x square का coefficient 1 था. Right now we are working with the quadratic polynomials in which the leading coefficient is not 1. I suppose assignment में आपके questions होंगे इस तरह के. Let's take up the next one. I've got px equals to 2x square plus 7x plus 3. And again, I'm going to write down what I need as the product and the sum to split my middle term. 2 multiplied by 3 is 6. And the middle term is 7, positive 7 to be specific.
1 into 6.
1 into 6. So I'm going to split
1
the
and
middle
6.
term. 1x plus 6x plus 3. I've split my middle term. And now I have to pair first, second, and third, fourth terms and take the common factors from these pairs. From the first two terms, I get only x common. and I'm left with 2x plus 1 here, and from the next two terms I get 3 common, and now you can see the binomial is same. The binomial will be same only if you've done the pairing, splitting correctly and you take common factor correctly. Sometimes you're taking a negative factor common. The signs will change inside the bracket. So this is your factorization for the given quadratic polynomial. Anyone with any questions? Because I'll be doing the next two parts quickly otherwise. So the third part is 6x squared plus 5x minus 6. The product required is negative 36 and the sum required is positive 5.
9 and minus 4.
9 and minus 4.
No, beta, actually, if you, just a minute, you are asking me if you could take 5x and 2x. One of the students is actually asking this. So I'm answering that. If you take 5x and 2x to split your middle term, you need the sum as 7, that's fine. 5 or 2 का sum 7 बनता है. But इनका product 6 नहीं बनता. यहाँ पे problem आएगी. So you cannot take 5 and 2. Okay. Right now we have this third part. I'm again going to show how we can factorize this 36 का जो हमें product बनाना है, minus 36 product बनाना है. How can we write down the factors? So one way was what we learned in junior classes by going this way. But अगर हम ये वाले पेयर्स यूज करते हैं तो इनसे तो प्रोडक्ट पॉजिटिव 36 बनता है. अब मुझे प्रोडक्ट बनाना है नेगेटिव
9 into minus 4.
या आई कैन डू दिस. यहाँ पे आपके पास स्मॉलर नंबर्स हैं, so you can think of these very quickly. So if you have larger numbers, this is how you can find out the factors for a negative number. This is how you will have. So this one works there. The sum is positive 5. Minus 4 and 9. Let's split up the middle term. And remember, the middle term has a positive sign, so the larger value will have positive sign with it. And you can write the terms in any order. I'm going to write it in this way. Plus 9 minus 4. 9 minus 4 will give you 5. And then you can just pair up. Pair up the first, second terms and third, fourth terms. And now from the last two terms, I've taken a negative factor common. The terms inside the bracket are going to change their signs. Earlier, they were both negative. Now the binomial inside the bracket will have both positive terms, 2x plus 3. And now the binomial is common. The monomials will be left inside. These are the two linear factors of the given polynomial.
Minus 4 plus 3.
Minus 4 plus 3, that's correct. Now deliberately changed the order so that I could pair easily. I've got 3x into x plus 1 minus 4 into x plus 1. And I've got the two linear factors of my quadratic polynomial. I hope everyone's now clear about factorization of quadratic polynomial. अगर फिर भी याद नहीं आया, do revise, and if you want questions for practice, I can give you those also. कि अगर आपको याद करना है and you need sums to practice. Okay. The next, okay, I'll share with you. Okay, anyone who's writing down, please let me know.
No.
The next question that we have is the factorization of a cubic polynomial. Okay, let me just go back, last part here. All right. So we had this polynomial, we had 3x square minus x minus 4. I'm going to write down the coefficient of the middle term here, which is not visible. It's 1 here, minus 1 here. So the product required is 3 multiplied with minus 4, that will be minus 12. And the sum that I require is negative 1. So as such, जो ऊपर मुझे numbers नजर आ रहे हैं, वही factors ही use हो जाएंगे, ये वाले दोनों. इनका प्रोडक्ट बन जाता है -12 और अगर मैं इनका सम लिखती हूँ the sum is -1 which I require. So these two factors work very fine and I have actually used them in a different order. I've used them in the same order as it's given in the expression. The leading coefficient is 3 and I've split my middle term with 3 then -4. I hope it's clear. Okay. Now let's discuss the factorization of a cubic polynomial. I'm going to first of all take the first part and I'll show you how this can be done in two ways. So I've got px equals to x cube minus 2x square minus x plus 2. First thing that I could do is always identify the polynomial by its degree, not by the number of terms. There is one question, sometimes it's asked, x cube minus 6x plus 7, something like this. So it just contains 3 terms and the leading term is actually a cubic term. But at the first instance, students think of it as a quadratic polynomial and they try to split the middle term, which doesn't help them except for just one thing they can do. They can split the middle term, that's it. So be careful, identify your polynomial by looking at the leading term. So leading term is cubic term, that means the polynomial is a cubic polynomial. Right now, if I look at this polynomial, I will see, now this is just an observation. Sometimes नहीं नजर आता, तो अगर नहीं नजर आ रहा फिर हम अपना लंबा वाला मेथड लगाएंगे, like पूरा detailed जो step by step method है. Right now, if you can simply do is just work with me here, and as I will show you, if you just compare the first pair of terms and the last pair of terms, you will see that if you take a factor common from these two terms, you'll have something left behind. So if I take x square common from the first two terms, I will have x minus 2 left. Let me know if this is clear. Yes. Okay. Now from the last two terms, the last pair that I have marked here, nothing is common. So I can take -1 common and it leaves x minus 2. So as for now, I can see a product or ये वाला product same binomial contain कर रहा है. It looks like I had split the middle term and I have same binomial. वही वाला step बन गया है जो splitting के बाद आप करते हो common लेके. And at this point, what you're supposed to do is you're supposed to take x minus 2 common and you'll be left with the monomials inside. Is that so?
Yes.
So this here is a linear factor. This is fine. Linear factor is okay. What I want to do is this here is a quadratic factor. I would like to factorize it further if possible.
X plus 1, x minus 1.
And this is not necessary that it will be always possible. So I've written here if possible. And इसका मतलब ये भी नहीं है कि अगर ये possible नहीं है तो सम यहीं पे खत्म हो जाएगा. हो सकता है आपको करना नहीं आता. And you have made a mistake somewhere in the previous steps. That's why you're not able to factorize your quadratic factor. So we would like to factorize this if possible. And right now, this particular quadratic polynomial resembles your identity a square minus b square. And this can be split up into two factors, sum of the terms and difference of the terms. And the first factor is as such along with them. So these are the 3 linear factors of given cubic polynomial. This is how I can write them. कि px has been now written as the product of 3 linear factors. अगर हम तीनों को मल्टीप्लाई कर देंगे हमें हमारा ओरिजिनल पॉलिनोमियल वापस मिल जाएगा. I hope this is clear because this is very simple. This just looks like I am factorizing a quadratic polynomial. मैंने middle term split की, पहली दो में से कुछ कॉमन निकाला, लास्ट दो में से कुछ कॉमन निकाला, लेकिन क्वाड्रेटिक पॉलिनोमियल की फैक्टराइजेशन वहां खत्म हो जाती है. उसके बाद आप बाइनोमियल कॉमन लेते हो और एक ब्रैकेट क्रिएट हो जाती है, दैट्स इट. बट हियर आपके पास जो दो ब्रैकेट्स क्रिएट हुई हैं, one of them contains a linear factor and the second bracket contains a quadratic factor, and I would like to factorize the quadratic factor further if possible. Is this clear?
Yes, ma'am.
if you can identify कि आपका cubic polynomial इस तरह से factorize हो सकता है तो आप कर सकते हो अपना question. आप अपना question ऐसे कर सकते हो. But what if you are not able to see this thing in other cubic polynomials? Now you could take the example of second part here. अगर यही वाली चीज आप यहाँ कोशिश करो यूज करने की सेकेंड वाले एक्सप्रेशन में तो ये वर्क नहीं करेगी. आप कोई भी दो टर्म्स पेयर अप कर लो, ये काम नहीं चलेगा यहाँ पे. सो इस केस में or rather in any cubic polynomial you can use a generalized method which I'm going to discuss with you, and I would like you to just watch before you write down. Maybe some of you have already done. So I'm going to take the first part again which we just did. This is what we have, and I would like you to start by the first step where we want to find a zero of px. We are just looking for 1 0. This is a cubic polynomial. इसकी maximum 3 zeros होंगी, but हमें सिर्फ एक चाहिए. And I hope you remember what we mean by zero of polynomial. Zero means we are looking for a constant value which if used in place of the variable will make the polynomial equal to 0. ऐसी वैल्यू जो पॉलिनोमियल में पुट करें और उसका आंसर जीरो हो जाए उसको जीरो बोलेंगे. तो हम वो ढूंढने की कोशिश कर रहे हैं. एंड यू आर नॉट गोइंग टू यूज ट्रायल एंड एरर एज सच. देयर इज अ condition you can use. So always start with your constant term. Constant term is 2 and look at the factors of this constant term. So you will have a positive 1 as its factor, negative 1 as its factor, positive 2 as its factor, negative 2 as its factor. And you are going to try the values out of these. आप लिखने से पहले माइंड में भी कर सकते हो कि कौन सी वैल्यू यूज करें तो पॉलिनोमियल जीरो बनेगा. And here I am going to do trial and error. Let's start with the first value, first factor. Does this make the polynomial equal to 0?
Yes, ma'am.
So this will be 3 minus 3 equals to 0. So from here I can write down this value is a 0 of px, and from here I can now create a factor. This is where I'm going to use my factor theorem. I've obtained one factor of px. This is the first step. I had found a 0, and with the help of that 0, I have obtained a factor of px. Once you have obtained the factor of px, the next step will be to divide your polynomial by this factor. And the reason I'm doing this is just like prime factorization. Let us say you were given the prime factorization of 72 to be done. You first of all find out a prime factor that will divide 72 completely. So since it's an even number, it will be divisible by the prime 2. And the next step is to divide these two and obtain the quotient. This is what I have done here for an algebraic expression. पहले आपको ये ढूंढना है कि ये किससे डिवाइड होता है, फिर उससे डिवाइड भी करना है, so that you can work out the next step. 72 के लिए प्राइम ढूंढा 2 से डिवाइड किया, आपको नेक्स्ट फैक्टर मिलेगा 36, and then you can work out with 36. So this is what I'm going to do here. I know that my polynomial px will be divisible by x minus 1, and this is where you will need to divide in fair work, and this is not an option here, you will have to divide out. आपको करना है यहाँ पे x minus 1 as the divisor and your px will be the dividend. If you remember the division, I'm going to do that directly now. So the first term of the quotient will be x square, and I will have changing the signs. The leading term gets cancelled. I'm left with minus x square, and then I can bring these terms here. You can do it one by one also. I've just brought the polynomial all together. And then I will obtain the next term in my quotient, that will be minus x. Subtracting again, changing the signs. This gets cancelled. I'm left with minus 2x plus 2. And then the third term, it will be minus 2. Subtracting, the signs change and both are cancelled. This is must. Remainder must be equal to 0. Because we have obtained a factor, that would mean there will be complete division. Complete division means the remainder should be equal to 0. अगर remainder 0 नहीं आ रहा, आपने या तो ऊपर factor गलत बनाया है या आपने division गलत की है. So at every step you can verify whether or not you are going in the right direction. You would know from the sum that you are doing. Question खुद आपको help करेगा to find out कि आप ठीक चल रहे हो कि गलत कर रहे हो. यहाँ पे अगर आपका remainder 0 नहीं आता, that means you have made a mistake somewhere. Go back and recheck your answer. Once you've done this, once you've divided your polynomial by the factor that you obtained on your own, we have step number 3. Step number 3 would be, जैसे हम 72 को लिख सकते हैं 2 multiplied with 36. This is how I'm going to write down. This was my dividend, and this was the divisor, and this was the quotient. This is what I'm going to do here. So I'm going to write down px equals to, the divisor is x minus 1 multiplied by my quotient, which is x square minus x minus 2. Now comparing this with the factorization of 72, 36 can be factorized further. Same way, this quadratic polynomial can be factorized further. And now you will be using that splitting the middle term. Split the middle term of this quadratic polynomial. You could do it on a side here, or you can work out with this polynomial right here. And please carry this linear factor side by side. And I'm going to split the middle term here. I've got x square minus 2x plus 1 minus 2 minus 1x. And from here, I will have x into x minus 2 plus 1 into x minus 2. This is me working with quadratic polynomial factorization. And from here, you will have 3 linear factors. So I'm going to just help you revise this again from the beginning, so that you know what we have done. The first step is to obtain a 0 of px. और ज़ीरो ढूंढने का पर्पस ये है कि जब जब आपको पॉलिनॉमियल की ज़ीरो मिल जाएगी उससे आप पॉलिनॉमियल का फैक्टर बना सकते हो। और ज़ीरो ढूंढने के लिए आपको कोई अपनी तरफ से वैल्यू यूज़ करने की ज़रूरत नहीं है। देयर इज़ अ ट्रिक, अपने पॉलिनॉमियल में जो कांस्टेंट टर्म है आप उसके फैक्टर्स की लिस्ट बना लो, उन फैक्टर्स में से ही आप कोई वैल्यू ट्राई करके देख सकते हो कि किस पर्टिकुलर वैल्यू से पॉलिनॉमियल का आंसर ज़ीरो बनता है। So this is the first step that you want to do. Start with your constant term. उस constant term के factors लिखो, उन factors की list में से कोई ऐसी value ढूंढ लो जिसको अगर आप अपने polynomial में put करते हो तो उससे आंसर जीरो बन जाए। And here मेरी पहली value से ही आंसर जीरो बन गया। पहली वैल्यू से आंसर जब जीरो बना, दैट मीन्स 1 इज एक्चुअली अ जीरो ऑफ px। उस 1 से मैंने फैक्टर क्रिएट कर लिया x माइनस 1। जब आपको एक फैक्टर मिल जाएगा आपने अपने पॉलिनॉमियल को उस फैक्टर से डिवाइड कर देना है यूजिंग दैट लॉन्ग डिवीजन वी डिस्कस्ड अर्लियर। आपकी जब डिवीजन कंप्लीट हो जाएगी द रिमाइंडर मस्ट